What are we doing? Oh, we're doing, okay. Yeah, so today we are going to be doing JSON XML, okay? So this part, so real quick, while I close these guys up, kind of give me a thumbs up, thumbs down. Who has used either JSON or XML formats before? See some thumbs up, mostly thumbs down. Okay, that's fine. So we'll talk about what this is. So as data scientists, we will have to deal with data. So it's useful to know what these formats kind of come out. And that's essentially what XML and JSON will be useful for. So I'll talk a little bit about what these things are. These are the two really common formats, basically are usually used to pass information back and forth to different computers and such. I'll kind of mention this a little bit as I go through like what JSON is, what XML is, but JSON tends to be more common now than XML. XML tends to be kind of like considered like old school, still around, still very useful, but usually all the new kids like using JSON and everything because you'll see why it's kind of useful for how we develop things. And you can see it in the development of packages and functions that are used for JSON. So we'll see why that's easier. So JSON.
We'll come across XML.
I'm sorry?
Do you think we'll come across XML in like the working world?
Definitely. It's one of those things that's like if you, for how to say this, if you're dealing with the web, you likely will see JSON a lot more than XML, but there's so many older enterprise businesses that have just used XML for so long that most of them expect XML as a format. And so you likely will get across. Like for example, when I was working with a credit union, they're using XML. Like that's essentially what they're using to organize their information and pass the data back and forth. So it's useful to know how to do it. But in reality, you probably will want to convert XML to JSON because it's so much nicer. And you'll see what I'm talking about in a second. But a good question. Okay. So JSON represents not JSON, but JSON, right? So JavaScript object notation. So basically, if you are familiar what JavaScript is another programming language, mostly used for the web. There's some other stuff you can do, everything like that. But basically, that's what this is coming from. Essentially, JSON is valid JavaScript, which is kind of cool. So basically, by knowing some JSON, you actually already know JavaScript. Yay, it's nice and easy. So basically, though, you'll notice a few things there. Object notation. Well, we just learned about objects, right? Objects are classes and stuff like that. So it turns out in JavaScript, it's actually really, really easy to make objects. And essentially that's what this right here, this is a JSON format right here, is actually an object. And I actually just realized I can probably change this. Come on, Jupyter Notebook, give me something good. Ah, yes, okay, it's not that much better. But anyway, it just kind of highlighted parts of it. So JSON right here, essentially is you kind of notice these curly braces, some colons and stuff like this. And if you look at this really quickly, if I didn't tell you it was JSON, you probably might think what this might be. If you were looking at this in Python, what does this look like to you?
Dictionary.
Dictionary, yeah, good, right? So this curly brace, you might even see if you look carefully, there's actually like a list in here too, right? So you can actually see like almost like this key of the dictionary is pointing to another list. And you can actually do this in Python, like a dictionary of dictionaries or dictionary of lists of dictionaries and so on. So this actually looks like Python. And it turns out that's gonna be really useful for us later on. But the main thing you have to realize is that in JSON, there are basically all of these types that you can have in it and basically nothing else. You can have objects. So basically objects in JSON are going to be dictionaries. So this right here, this whole thing is an object by itself. So all JSON is wrapped around with these curly braces. And then this right here, from here to, well, here would be another object right here. So basically other properties. You can think of like ID as a property, value as a property, pop-up as a property, and so on, okay? Next part we can have as arrays, which in Python speak, we usually refer to them like as lists, right? So this right here is an array in JavaScript. We can also have strings, which we can see right here. So we can put strings as keys, or we can put strings as actual values, right? Just like a dictionary. We can have numbers. There's no numbers in this, but you could replace this file, for example, with like a number. Boolean, true, and false. So this is an important part. In Python, Booleans are either capital true or capital false, right? So lower or capital T, capital F. In JavaScript, these things are always lowercase. So true and false, they won't have any quotes around them, but they'll be lowercase. So note there's that slight difference between the two, okay? And then going into further another difference, there's something called a null value. And you guys probably have heard like null value at this point. Null value is kind of equivalent to like, you know, empty. So what would be the equivalent of an empty value in Python?
None.
None, right? So nothing, right? That's essentially what Python's equivalent of null is. In JavaScript, it's just null. And it's just essentially like just like a number or a Boolean. It would just be null with no quotations. Okay, so in Python then, what's cool is that we can actually take a JSON object, okay, and we can actually convert it into Python. So just like we saw before, objects are dictionaries, arrays are list, strings are strings, numbers are numbers, and then Booleans are the same thing, but there's a capital T and lowercase, or capital T and capital F, and nulls are nuns. So that's kind of like what kind of goes through. And what's nice is we actually have a package already built into Python. You don't have to install anything, called import JSON, okay? And what this will do, this right here is going to open up a file and save that file, essentially that reference as F. And what we can do then is take JSON and we can load that file into this variable right here. So just to show you what the sample.json looks like, I'm going to show you what that looks like. So this right here is my big old JSON file. So you can see here, it's pretty big, right? About 1,000 lines. So you can see here, this starts with an object, right? And then we can see in this part is that, well, this is a little hard because it's not formatted well, but you can see here is that our first key is meta and our second key is data. So this will actually be a dictionary. And then for in that first key right here, or sorry, that second key, data, you can see actually it's a list of, looks like other list. So you can see here, this is going to be a big old list. And if I were to minimize this, I can't minimize it completely, but if I were to scroll to the bottom, you'll see that that's the only other key. So the data list, basically, or the data key, which refers to a list, ends right here. And then within that point, you'll see that there is basically a bunch of different lists within there. With meta, we can see it's actually pointing to another dictionary. Okay, and then the first key is view, and it looks like that's the only key in that case. And that key here points to another dictionary, and you can see how deep we can go through. And then in that dictionary, we have ID, name, attribute, all these things up to columns. And you can see there's now even more nesting of columns, which is pointing to a list of dictionaries. And in that dictionary, you have a bunch of other things like numbers and letter or strings and all that stuff. So this is kind of like what JSON can actually build up. Basically, using all those like what 5 or 6 different types, you can build up this whole thing. Okay. So we're going to load this into our actual thing. So we can actually use some legitimate Pythons. So I'm going to split this up to build up more suspense. I imported in here pretty quick. That means data now has all the contents of sample.json. So if we actually print out data, we'll actually see here, hey, look, we can see that this guy right here has meta, like we saw before. And if I were to scroll down further, I'd probably not be able to find it, but you would find data somewhere. It's so weird right now. Basically, you can see all the information passing through here. So to kind of show you that this is in fact valid Python, we can write the type, and you can see the type of data. This is probably not the best word. I should probably use D. That probably makes more sense because there's a key that's called data. So that means that this whole thing right here is a dictionary, right? If I do D meta, right? So I'm getting that first key, meta, okay? We can see that's also going to be a dictionary, right? I can go further into there. It's like, okay, that's a dictionary. Let's go into view and let's go into ID. So that will probably be our first one. So I need to now do view, and if I do ID, we can now see our first one is a string. So you can see that's where our property is here. And I can actually print this value out. If I go like this, you can actually see it's a string right here. I could also have done something like, let's pick a, I don't know, let's do number of comments, right? So number of comments. And you can see here, 0, which is there. Okay. Simple enough, right? Makes sense so far? Cool. All right, also note that I could have done data since I know what the key is. I can have done data. If I try doing this, this will give me an error since it probably doesn't have the word view. You can see here, view doesn't work, right? So if I do data and print this part out, you can see it's a bunch of lists. So I can actually say, oh, how long is this list, right? And say, oh, this list is 285 elements. So that means each element in that data part will have a different, well, there's 285 elements in that list within data. Okay, cool. Everyone follow along so far? Awesome. So now we can say, all right, cool. Let's go ahead and make a data frame, right? Because we love data frames. We're using pandas all the time, right? As data scientists. So like I showed before, if you didn't know already from the JSON file, we can actually say, well, what are the first few keys? Like we know meta is one of them, and we'll see that data should be the other one. So in this case, it only has 2 keys. We also could have had, well, I guess it's not, it should be D because I changed it up on you guys. But you can see here, if I want to do data or d.meta, which we know is also a key, or let's do .view. You can see here, oops, sorry, I forgot that we're not. There we go. So I'll get basically the first dictionary, which is going to be view, or it's like for meta, it should be this dictionary here. I'm going to go ahead and grab the first key within that dictionary. And then within that, we should see some keys. And you can see here, these are all the different keys. In this case, ID, name, attribution. You can see ID, name, attribution. So this is kind of like how you can kind of quickly explore a little bit to see specifically like what are these different properties and stuff. Okay. Note that I have data from an older time, so I'm just putting D here. But you can see we can actually load and say, okay, let's go ahead and take meta and load it as a dictionary itself. And so let's go ahead and load this guy up. And if I want to then see what this looks like, let's do .head. And you can see here, basically, it just took in, this is true for any from dictionary. You can do this for, doesn't have to be JSON. But you can see here, basically, each row is going to be related to, what is this case? We have view. Basically, it's going to be all these different parts within here. So you can see here, there's ID, name, attribution, average, category. So this is a little confusing. Basically, it's using these parts right here as its index. And then you can see these different parts within view. Now note that there's some weirdness, like especially at these columns part, you'll see that there's this long thing. That's because data frames can only contain essentially numbers, string objects, and null values essentially. It can't do things like another list within a data frame. So what this is coming out as, if I actually did say info, okay, you can see here, oh no, that's not really helpful. Describe, that won't help either. I'm trying to think of a good way to show this. But if I were to look at that specific column right here, this guy right here, you would see that this is actually a string going through. It's not actually a list or a dictionary. Okay, so I'll do something similar with data in this case. So I'll do data.head, and we can see here in this case, it's a little bit more useful. Because remember, if we did, let's try it up here. And I'm kind of moving around for you guys, but hopefully you guys are kind of following all right. You can see our data basically is a list of stuff, right? So you'll see here, it's like, okay, that means each of these rows here is an element within that data key. So you can see here, there's all this part, but you can see, for example, like this part, we actually have another dictionary and it's just reading it as a string. Also know that there'll be some interesting parts. You'll see none right here. Okay, and that's because these parts don't exist. That specific column doesn't exist for that list. Because remember, a list can be as whatever size we want. So there might be some funniness. So this is going to be like where you would do a lot of cleaning, for example, and trying to make sure you understand what it is. In reality, people have asked me before, like, you know, how do you know like how you should approach a JSON file? In reality, you kind of don't. You kind of just have to explore it and know what kind of file you're getting. Usually you would not just simply take your JSON, a random JSON file or a random JSON, you know, string and load it into a data frame, because you'll probably get weirdness like this. You probably have to know ahead of time or explore it a little bit ahead of time to see what exactly is in here before you go ahead and do this. So this will be important because JSON is mostly used in, well, APIs will use JSON typically. Will pass you a JSON string. And that's what we'll talk about tomorrow with APIs is you basically say, you go to another computer, say, hey, you tap the computer on the shoulder, say, hey, do you mind giving me this information? And then it gives you the information in a JSON format. So the reason why it does, well, usually it'll do a JSON format. And the reason why it does JSON format is because people kind of know what to expect. It's relatively simple. And most programming languages like Python directly wrap itself around JSON. So you can see like how we have dictionaries and lists built in already. Okay, does that make sense to everyone? Okay, any questions on any of this stuff so far? Okay, cool. All right, so now let's say we've gotten some data, right? We put put it all together. A lot of times you might have to pass the information back to a computer, right? Or to a server. This would be really common API. So the computer doesn't know Python, or like the server doesn't know what Python is. So you have to output into a format that it's familiar with. And usually that will be JSON. So it's useful to know how to output that JSON itself. So what's kind of cool is that if you have a Python, this is like, if you look at this right here, this is legitimate Python code, right? There's nothing, there's no, you shouldn't get any errors or anything like that. So if I actually run, right, if I do, I called it data again. I'm sorry, it's probably not the best way for me to describe this since data could be used in here. But if I do menu, right, I can actually get other parts in here. And if I wanted to get, you know, let's say I get pop-up, right? Okay, and then let's say I do a menu item. Okay, you can see here I have a list right here, right, of all these different parts. So this is all legitimate Python, right? So I don't have to like do anything special. So it's nice that I already have legitimate Python of dictionary, list, true and false, and I'll show you real quickly. I'm going to change this over to true. Okay, so that's all legitimate Python still works fine. I can actually output this now as an actual file. So I can actually convert this into a file into JSON format and actually print this out to, you know, or let's send this file over to the server that's accepting JSON. So this is probably the most funkiest stuff with files. I don't know if has anyone seen this yet with this with open part. Okay, you might have seen it. A lot of people are like, I don't know what's going on here. The main thing you have to realize is that basically this F right here as F is saying this is going to be our file. Essentially, this part right here is a nice way for us so we don't have to open and close the file. This might not be super clear if you're not as familiar with like the computer science parts, but basically when we open up a file, we have to make sure we close it. Otherwise it stays open in memory and does this weird stuff. So with basically it's this really nice shortcut where we like, hey, open the file and then close it once you're done with all this stuff underneath here. Otherwise you might see something like you literally will see like dot open and then dot close and stuff like that. So this is us in Python being able to avoid this. So you'll see this idiom right here used quite often. But going through that, saying with this part, open up this file name. So this might not actually exist, right? We're going to write to it. That's what this W represents. And then we're just referencing this whole file that we just opened, possibly even created. We'll call it F, okay? And then we're just going to JSON, which is a package we imported. We're going to dump all the information, which is this guy right here, right? Some legitimate Python code, a dictionary, right? The dictionary could be built up of a bunch of different parts. And we're gonna dump that data into the file F, okay, which should be this guy right here. So I'm actually gonna delete my earlier code right here so we don't do anything weird. So you can see there's no file here. And if I go ahead and run this now, what this will do, make sure I run this part. So, okay, good. And I'm gonna run this part and now it will actually output this into right here. And you'll see my output.json now, a few seconds ago was made. I can go and open it up and you can see here, it's not nice and formatted, but you'll see that's actually proper JSON format. Okay, so that's the way you can basically take something that's in Python code and convert it over into JSON and then pass it on to whoever you need to next. Okay, cool. Pretty simple so far, right? Not too shabby. Okay, any questions on any of this JSON parts? Okay, cool. So real quickly, I do want to mention that you can, did I get rid of it? Oh, okay, maybe I'll show that. Oh, I think I showed it later. Okay, I will show you like comparing the two formats. So that's JSON. JSON, you know, it can be a little like cumbersome at first trying to get used to it, but it's relatively straightforward. Everything's either a dictionary, a list, a string, a number, a Boolean, or nothing, a null, right, or none. XML is kind of interesting. Has anyone done HTML before? Just give me a thumbs up if you've seen HTML or done it like the website. Cool. So XML stands for Extensible Markup Language. HTML, which is what the web's basically built on, which we'll talk about in the future, but at least briefly, is called Hypertext Markup Language. So extensible basically just essentially means you can make whatever you want. Markup language is saying like it's not really a programming language, it's much more saying this is a thing. So markup language in the XML, I should say, basically you can use like these what they call like tags, and these tags say, hey, this underneath here, is going to be a note until you hit the ending tag. So essentially this is marking and saying everything that's in here is part of note, okay? And then this part right here is everything is part of to. So essentially this right here is kind of like a note. You can see like, you know, Yana, it's from Bonnie, heading, don't forget, body, we're going to the party tomorrow, question mark. And you can see here, body, and that basically closing tag right here, which is represented with a backslash, or sorry, a forward slash body, okay? So that's essentially what XML is. Now, people sometimes ask me, but how do you know if to do note versus to versus from? That's the thing about XML, you can do whatever you want. You don't have to actually use specifically those tags. So that's why XML is very, you know, flexible and stuff like this. However, it's tend to considered old school compared to before. And you'll kind of see this come out in Python, especially because Python doesn't treat it very nicely. But know that you can basically parse through it and you can get the same idea here, where essentially everything is going to be equivalent to essentially like a dictionary, right? Like a key right here, and then there's going to be other elements in here. But no, that's the only way you can do stuff, okay? So we can actually have a built-in XML parser. A parser just means like it's reading through the material. It's built into Python already. So I'll show you what this looks like. Now, like I said, this is a little more complicated. I want to show you quickly an example XML, and this is a really big one. Oh, I forgot I did this last time. So let's see here if I can do, sorry. Let's do it this way. Let's do an edit. There we go. Nope, that's the wrong one. Okay. The reason why is because XML is used in the web, it thinks it is like HTML essentially, and it's trying to read this through. So actually, we just want to see this part. So you can see here all this big mess of stuff, right? So this is XML, and this tends to be older school. All my computers having a hard time reading all of it through. But anyway, this is kind of how you do it. Another way I can show this, and that's why, let's see if I can do this really quickly. Inspect. And a new window popped up, so I want to move this over. No, it's not what I wanted. There you are. Okay, so here we go. Here is, you know what, that's okay. I'm not gonna go. But this is similar to like XML, how it's structured through, kind of like hierarchy. This is technically at HTML. It technically would work as XML as well. But I just wanted to show you briefly what that looked like. Okay, so anyway, that's our XML. So now we'll actually go ahead and read it with Python, okay? And so note that there's kind of this funkiness. I'm not gonna go into full details exactly what's going on here, but essentially we're trying to parse through this specific file, sample.xml. We do something called a root. So they talk about this as being a tree, so you can imagine this being like the very start of the tree and then the branches that are coming off. So you can imagine like it's kind of nested within. We'll usually talk about it as an XML tree and parsing it through. So note that computer scientists do trees differently. Like when you picture a tree, you think of the roots are on the bottom and then like branches going up, right? Usually trees in computer science, they'll have, if I were to draw this out really quickly, this is just for you are educated. This will be the root right here, and then they'll draw these parts going forward like this. So just know, like, they write their trees upside down. I don't know, computer scientists, they're kind of weird. But anyway, you can imagine this right here as being like the root. So this would be note. And then each part would this be like to, for example, this would be from, right? And then we might have something like body right here. Okay. And then if we had like within that to, if we had another nested element, you might have like to, and this is like first name. So like first and then like last name here, it could branch into new parts and go further and further. So that's kind of like how you can branch out into making this tree. So what we're going to do, we're essentially going to use this to parse through, start at the top and kind of go into it. You also will hear those branches be referred to as children. So that kind of hopefully makes sense, like, oh, children, descendants, like, you know, you're moving kind of down the branch like a family tree. So you'll see me use that kind of terminology as well. So this will give me my root, which is basically this special XML tree element. And then we can actually get our first children. So I'm going to show you what this looks like. So, and you can see here basically, oh, of course I can't do anything because I can't print this out. Okay. Anyway, you can get for each node, which is kind of like us splitting off from the root. That's what our first children are. So if you imagine from this part, our first children would be to, from, heading, body, branches. Those would be the different children. If there were further ones in there, you can actually do a grandchild. So I'm kind of showing you some idioms. I think this is similar to the curriculum. You can see basically you can go, you could get the children, and then after getting children, you could do grandchild. But you could also do this in one fell swoop, where you do for node in root, and then for grandchild in node. So basically you're kind of going layer and layer and layer. And so this way I can get all the grandchildren going through. This is just kind of showing you how you can process it through. You'll notice that this is a little more difficult to travel through versus like Python's, JSON and stuff like that. So now what we can do, we can actually print out parts like the tag. So the tag basically is telling me what is this part right here. In this case, it would be like from. In this case, the first child, the first children 0, the first one is just row. Okay, that means the tag is says row. You can also do something called an attribute, and these attributes are going to be, this is something I kind of skipped over, is that it would look something like and I might do something like, I don't know, let's say gender equals, female. Okay, so this right here, this gender part would be an attribute. So this is kind of describing a thing, like it's describing that branch itself, that node. So this is, if you, again, HTML, you'd see this as like a class or like ID or something like that. These are different attributes. So you can actually grab those specific attributes. In this case, there's no attributes. So it'd be similar to this right here where there aren't attributes. If there weren't attributes, which we'll see in a bit, you'll see that it shows up as gender, okay, or whatever the attribute was. Okay, so then we can start seeing some things like, let's see like how many grandchildren there are. And then for the first grandchild, what the tag is, and then see if there's any attributes. So if we do this now, we can see there's 285 grandchildren. The next tag is confusingly a row. So it's actually like row. I want to say your boat, but row is your second tag in this case. And then your attributes are these guys. So you would actually see ID, UID, position, and note that these are the values for those certain attributes. So if I go to actually back to our sample XML, let's get that away. Here we go. You can see that's our first one. Our first child was row, and then our first grandchild of the first child is row, and this is the attribute ID underscore UID underscore position, and you can see the values for those attributes, and you can see that reflected right here, ID, UID, position, and that's what those attributes are right here. Okay, make sense so far? Okay, note that this first row right here, the next element in here is actually another, if I can kind of make quick space, if I do it like this, and then go into candid. So candid is basically the next element in there. And you can see here, this next candid will actually not have any attributes, but it does have inside of it is candid, the actual name. So we can see what that looks like. So again, we're at row, we're seeing the attributes, but let's go ahead and dig into this tree, right, to see like what's in there. And so we're kind of going down. In this case, I'm only going to go down 10 elements in. So this is just another way. I won't go completely through this. The curriculum kind of goes through more detail. But essentially, we're starting off at the very top at the root, and we're getting the response, which is the very first top. And then we're going in one element in deep, which is row, which is our first child. And then we go in any of those, which are our grandchildren. In this case, row is our first grandchild of the first child, right? And then going in deeper, so you can see here all the attributes as well, right? Going in deeper, we can actually see inside there is candid, which is our first great-grandchild. And then second great-grandchild is can name, office borough, can class, and so on, okay? And that's essentially how you can go through this node, what's it called, or go through this XML tree, going through it. Now note that I stopped at 10. You could technically keep going further. If, like you can see here, is that I reached the end of these great-grandchildren, and it pops out to the next part. So if I look back on here on my sample XML, I think I can do this relatively quickly. Yeah, you can see here's can class, and then we get actually the end of the row, and then we have a new row. So this is like our first grandchild, our great-grandchildren, and this is going to be our second grandchild right here. And I'll go into the next part so you can see election. And note that this is not the same structure. Like, it's not candid again. You can have whatever structure you want. Essentially, as long as you can write it in some kind of form like this, right, or with some attributes, it's valid XML. It doesn't have to be a specific name. It can be whatever you want. And that's what makes it really versatile. Okay. So that is how you can parse through it. I'll kind of quickly show you. Well, I guess real quick, are there any questions on this guy? Okay. I'll be honest, it's not super fun to look at. XML, in my opinion, makes me like my eyes kind of cross over a little bit, being like, ugh, like it doesn't seem as pretty as JSON. And then just quickly, this is directly from the curriculum, so I'm not going to walk through the whole thing. But basically, you can walk through this XML tree and try to build a data frame, for example. In this case, I was looking at just looking for the position, address, and UUID and creating a data frame. You can see, already, this is not fun compared to JSON. JSON was this nice dumps, dot load, nice and easy. XML is kind of treated as like the forgotten child. Like it's like, oh, like we're just gonna forget about you because we don't really like hanging out with you, I guess. I don't know. So anyway, that is XML. Quickly kind of looking this through, because I just have a couple more minutes, is we have JSON and XML. So this is literally using the same exact information, but comparing it with XML and JSON. So you can see JSON here with menu, and then with that menu ID, value. Oh, I can do this, yes. Yes, I should have done this before. There you go, look at that, it's all pretty and nice and neat. So we can see menu here, we basically the same information, and you can see here in this case, ID and file are actually used as attributes. There is no fast and strong rule of like why you couldn't have just done like ID and then like file within there. It just depends on what the person who creates the XML file, what makes sense and what they care about looking for. So note that this is pretty arbitrary, like what is an attribute versus an actual tag within. Okay, cool. Yeah, and then there's this little website, which is awesome, json.org, which can show you a whole bunch of different examples of like the similar JSON and XML formats going back and forth. So if you're kind of curious, like, well, what will this kind of look like? You can kind of see some examples going through. So really nifty website. Okay. All right, that kind of finishes things up. There is parts of the curriculum, which I do have a little lesson right here. Let's see here, data engineering. Well, actually it's going all the way to computer science called recursion. I'm not gonna go over through right now because we're out of time. Also, to be honest, it's probably more than you really need to go into. It's much more computer sciencey based. But no, the reason why we would use recursion for something like XML and JSON is because XML and JSON do not have a strict format. So you can basically dig as deep as nested stuff as you want. And you saw with XML, you can have it formatted in different ways and stuff like that. So recursion, you basically pay off the fact that you don't know what it looks like ahead of time with basically having it being very versatile. So recursion can do really well with nested in things where you don't know the structure ahead of time. Like think of like a list within a list within a list. You can see, like, for example, I have a quick example here, like this list right here, which is from the curriculum. You can see it's a bunch of lists within lists. So recursion does really well with this. If you try doing a for loop on this, good luck. You're gonna have a hard time trying to figure out making nested for loops and when you have the right amount of for loops. And if I add, you know, for example, one extra list like this, like how do you deal with that? It's like, well, I wasn't expecting that. Recursion does really well on dealing with these kind of structures, which is similar to JSON and XML. Okay, cool. And so tomorrow we will talk about APIs, which is pretty fun, which will basically be using JSON and everything like that. And basically we can use it to get data or send information or control things. Like tomorrow I'll show you guys. I think I'm gonna give you guys access to control my smart home. So that's gonna be kind of fun. So yeah, I thought you guys would like that. All right, so I'll stop that here.